In this video, I'm going to walk you through how to build a stack out of a vector. A vector does almost everything we want to do for a stack, except keep track of a couple of different things, and it doesn't give us quite the names of member functions that we'd like. So what we're going to do is we're going to build a stack using a vector inside to do most of the work for us. Okay, so for that, what we're going to do is we're going to switch and actually look at an implementation before coming back to some slides. Okay, so here we are in the main.cpp file because I want to show you how we want to use the stack before we actually define it. So we have a stack header file that we're including here, and then in here we have some functions that are using the stack. So the first thing is that we have a little function called fn1 that takes a stack. Notice this makes a copy of the stack because it's not by reference, so our stack better support being able to be copied. Here we print out the stack, so our stack better support the less than operator. And then we're using some functions on a stack. So for instance here we're asking, is the stack empty? If it's not, we can pop elements off it. Then what we can do is we have a little loop here, and each time we go through the loop we're pushing something onto the stack. It looks like we're pushing a character onto the stack. And then afterwards we see out what the state of the stack is. Okay, and in our main function, we're doing a lot of stuff with stacks. One thing that we're doing right here is we're initializing a stack with what's called an initializer list. You guys have been using initializer lists quite a bit to initialize things like arrays and vectors. And then here we're couting what the stack is. We're couting, for instance, what the top of the stack, the thing on the top of a stack is. We're pushing and popping and pushing values off of the stack. And you're seeing us, once again, calling a bunch of member functions like empty. The other thing to note is that sometimes we can pop things off the stack. And here we expect a particular exception if we pop things off of a stack that's already empty. So sometimes our class will raise exceptions. And we can also raise an exception if we try to get the top of the stack when there's nothing in the stack. The stack also supports a clear, which deletes everything in the stack. And here we're using the stack to do some interesting things. So for instance, we're using a stack to read in a bunch of letters, and then we're pushing each of those things onto the stack. And then we're getting the reverse from the stack by popping everything off the stack in the reverse order that we pushed it on. But once again, the exact details on what's happening in this main function aren't especially important. The important thing is that we have this type that we're allowed to do things like call, push, and pop on, and it's able to remember things that it's stored. Okay, so let's switch to the header file for the stack. So once again, we have a stack. And as a private variable, we have a vector of characters. And here, once again, we end it with an underscore because that's the naming convention. Now, this private vector should never be used by anybody outside the stack. That's just an implementation detail. The users of the stack are going to be calling these member functions, top, pop, push, empty, clear. It needs to support the operator less than so we can print out a stack. We want to support a default constructor for the stack. And here we can just set the default constructor to be equal to default. What does this mean? It means that when we make an empty stack, we're just going to have an empty vector. The default works perfectly fine. Now this is something that you probably haven't seen before. Another version of a stack constructor takes an initializer list. If you go back to, let's go back to the main program. We used an initializer list to construct the stack right here. So here I'm saying I want the stack to start with these three things. And so this is actually calling a specific version of the constructor. It's calling a constructor that takes an initializer list. Note that I have to include it from the initializer list library. It takes an initializer list of characters, and it's named C. And what does this constructor need to do? Well, it's real easy. All it needs to do is say, I want to initialize my vector with all of those elements, all of the elements in C. So once again, most of the work we're just passing off to the vector. What's happening here is we have a bunch of member functions that we're going to define in our implementation file. Here we have a friend function, operator less than, which just like all the other operator lessons, it takes a reference to an O stream, and here, let's fix the name of that, and a constant reference to the stack. We can also have a non-member function, non-friend function as well if we would like. Okay, so now let's go to the implementation, into the implementation right here. So how do we work with the vector to make a stack? Well, it's real easy. What we're going to do is the stack is just going to be the using that vector to hold all of our information. And so the top of the stack will be the last thing in the vector. We're going to keep adding things to the end of the vector. However, if the vector is equal to 0, the size of the vector is equal to 0, it means there's nothing in the vector. We shouldn't return vec.back. Instead, we're going to throw this exception to indicate, hey, you're not allowed to call top when there's nothing in the vector because we don't have anything to give you back. Now, what happens when we pop onto a vector? Remember, pop is removing the top thing from the vector. So in the same way, if the size of the vector is 0, we throw an underflow error. Otherwise, we pop the last thing in that vector. And we can use pop back because, once again, this is a nice member function provided by the vector, which just says remove the last thing from my vector. All right, how do we do push? Well, push should take in a character, and here we're pushing that character onto the back of the vector. And once again, most of our work we're just passing off onto the vector because vector does almost everything else we want already. We want to support the empty member function, which returns true if the stack is empty. Well, we can just return whether or not the vector thinks it's empty. What do we do when we want to clear a stack? We just call clear on the vector. And then down here, we have our operator less than, which, once again, takes a reference to an O stream. It takes a stack. What we're doing here is we're just outputting the stack to this stream. So here we're outputting, here's the bottom of the stack. And then we're using the copy algorithm to copy all of the elements in the vector from beginning to end and copy it to this output stream. Here, let me indent this to make it align a little bit better. And then the last thing we output is the top, because remember, we're going in order from our vector from beginning to end. So the first thing in our vector is the bottom of the stack. The last thing in the vector is the most recent things we've pushed onto it, and that's the top of the stack. And here we can return the output stream so that these lessons can be chained again. Okay, so I've shown you the implementation for the various member functions that a stack needs to support. So for instance, popping the top element off, asking what the top element in the stack is, pushing new values, making a new top element, asking if the vector is empty or not, and then the clear member function, which should remove everything in the stack so you get a nice, clean, empty stack. Okay. So one thing that I had to consider when I was implementing these member functions was the fact that if you call pop or the top member function on an empty stack, what should happen there? You can't pop something off an empty data structure, and you can't ask for what's on the top of an empty data structure. There's nothing there. The first option I considered was possibly returning a set null value. So returning a value that indicates that the previous operation didn't have any effect. However, there are a lot of problems with returning a set null value. So for instance, right now our stack only holds characters, but in the future we might want to make a stack that can hold ints or strings or other vectors or something more complicated. And what we need to return as a indication that something went wrong for each of those different options, it's not really clear. Another big problem here is that, like, for instance, pop doesn't return anything. It's a void member function. So it can't possibly indicate that there was no operation that happened. So that neither of those options, like returning a set null value, doesn't work all that great. A perhaps better option would be to create a specific error type. Like, for instance, we might make a custom error type called, like, stack operation not allowed or something, or stack doesn't work with on empty or something like that. Some specific exception that represents what the problem is so that the user can get information about, like, oh, I shouldn't have called this method at this time. That's really probably the best option, but because I haven't taught you guys how to make custom exceptions yet, and you will learn how to do those in later classes, it's not something that I can really have you guys do just yet. The best compromise solution was to throw an existing exception. So I went and looked at all the exceptions that were in the std except library, and I found the one that most closely matched my problem, which was an underflow error, meaning, our data structure can't get any smaller, can't get any lower than this. And so I raised that exception. Probably not, once again, the best option. The best option would probably be to make my own custom exception, but that's beyond your guys' skill level at this point. Okay, and so this, once again, is what the data looks like. Okay, so the title for this video is a composite class. Now, what does that mean? A composite class is a class that's basically built out of other classes to implement their functionality. So for instance, the stack that I showed you guys right here is implemented on top of a vector. The vector is the one that's doing most of the work. This is built out of that vector. This is one way to basically take the functionality from a vector and present it as a stack. Now, there are other ways to achieve this same effect. One very prominent one is called inheritance, but you'll be learning about that in a later class. And in that later class, you'll learn about the pros and cons for using composition, building classes out of other classes, versus inheritance. But because I'm not teaching you about inheritance, you don't have to worry about that here.